No,
No,
ma'am.
ma'am.
Ma'am, recording.
No, ma'am.
Recording
Now
is
it's
being
started,
right now.
Now I think it is started.
Yes,
Yes,
ma'am.
yes,
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 ma'am.
ma'am.
Now it is started.
yes, ma'am.
yes, ma'am. Now it is started.
Okay. Mute yourself, all of you. Now see, for maximum minima of two variables, we'll consider one function. Let fxy be a function of two independent variables x and y, and we are also assuming that f is continuous and finite for all the values of xy in the neighborhood of their values ab. Okay. Now the value of ab, the value of f of ab is said to be maximum or minimum if mute yourself, all of you, please. If this expression f of a plus h b plus k minus f of ab keeps same sign, either it will be positive or negative for all positive or negative small values of h and k. So then this point, the point AB, is called extreme point. Extreme point can be maximum point, can be minimum point. So both maximum point, minimum point is also referred as extreme points. So what I have written, that we have considered a function. We are saying that if AB will be maximum or minimum depending on sign of this expression. Okay, if A plus H comma B plus K minus f of AB, if it keeps the same sign for all positive, negative, small values of H and K. Now the values f of AB, this f of AB will be maximum if the difference in equation 1, let me name it equation number 1. Okay. In equation 1 is negative for all positive and negative small values of H and K. And minimum, if AB will be minimum, if the difference in equation 1 is positive. Okay. For all positive and negative small values of H and K. That has been depending on this only, we can say whether f of AB is, if this value is negative, means less than 0. Okay. Then what we are saying that if AB will be maximum, which is very obvious because for all values C, what we will write, it is less than f of AB. That is mean what? If AB is the maximum value, similarly for greater than 0, it will be minimum. Now we have some necessary and sufficient condition for being extrema. So the necessary condition for extrema. Now see this f of x plus h y plus k. This can be, we can just use Taylor's theorem and we can write it as f of xy plus h del f del x plus k del f del y plus terms of second and higher order. This we can write if we use Taylor's theorem for two variables. We'll be writing this, or we can write f
We
of.
don't know Taylor's theorem for two variables.
Okay, that I will teach you. Okay. For the time being, you just keep in your mind that this is, if this is how we write the Taylor's theorem, we will explain afterwards. Taylor's and Maclaurin's for two variables, I'm going to teach you. So I can write in this way. Now see, for extrema means always I mean to say either maxima or minima. So together we say extrema. That is extreme values. So for extrema, f of x plus h y plus k minus f of xy must preserve the same sign. Now see, for sufficiently small values of h and k, this expression will depend on the sign of h del f del x plus k del f del y. And the sign of the first degree terms depends on the signs of h and k. So the necessary condition for the existence of extrema is h del f del x plus k del f del y equals to 0. So this is the necessary condition for existence of extrema. But h and k are independent increments. So we can write, as h and k are independent increments of x and y, so this equation will hold if del f del x equals to 0 and del f del y equals to 0. So this is the necessary condition of maximum minimum, that first order partial derivatives will be 0. But these are necessary conditions, they are not at all sufficient. Okay. So,
Ma'am, but how are
Ma'am,
you
what is the difference
partial
between
derivative
necessary and
condition?
sufficient condition?
yeah, coming to it. Now, if you solve these equations for x and y, we get the values of the variable for which fxy will be either maximum or minimum. Okay. Solving these equations, which equations? Del f del x equals to 0, del f del y equals to 0. Solving these equations, we obtain the values of xy for which f of xy is either maximum or minimum. Now, why it is saying that these conditions are necessary, not sufficient? Let me take one example. Okay, just let me write note. This condition is necessary and not sufficient. Means what? If you get del f del x equals to 0, del f del y equals to 0, doesn't mean that you will get a extreme point. But for getting extreme point, it is necessary that del f del x will be 0, del f del y equals to 0. Let me take an example, then you will be understand more clearly.
Ma'am, but before that, ma'am, that thing f of x plus h comma f of y plus k minus f of xy has the same sign. So how does that implies that this del f del x and this term equal to 0? How is that implying?
I derived it, no? Just now I derived it from Taylor's theorem.
Yes,
Does
ma'am,
not
but
get
that term is equal to 0, but how does that implies that we are getting maximum or minimum? Like in the you written a same sign for the difference. So
If you
how
do
does
not
that
have the
imply?
same sign, then how you'll get the, like, if once you are getting negative, once you are getting positive, then can you claim that it is a maximum value or minimum value? You cannot claim,
Oh,
no?
ma'am, that is fine. That is fine. I understood that. But after that, which you have written the partial derivative should be.
This is the derivation for the necessary condition. This is I have derived to obtain the necessary condition for getting the extreme values. That is different thing. And which I am saying that it should keep the same sign. That is very obvious, no? If you have different sign at different times, that is you cannot claim that this is the minimum point or maximum point.
Yes, ma'am. But in continuation, you're writing now that it should have the same sign, and then
Yes,
you're
it should have
implying
the.
that it's del of del x plus k del f del y equal to 0. Ma'am, that I couldn't understand from this step to that step.
Ma'am,
How is it implying
ma'am,
that?
maybe
Okay,
he
okay.
is asking
Let me
like,
first complete it. Let me complete it. Let me complete it. So here we are considering a function fxy equals to mod x plus mod y. Now see, this has a minimum at 0, 0. But del f del x and del f del y do not exist at 0, 0. Do they exist? Del f del
ma'am,
x and del f
is
del
the
y?
minimum at 0?
no.
They do not exist. But still we are getting 0, 0 as a minimum point. That does mean what? The condition is necessary but not sufficient. Okay. So in support of this statement, this example I have taken. Now let me come to the sufficient condition. What is the sufficient condition for extrema?
Ma'am, please again explain the difference between necessary and sufficient. Means,
The word itself it is explaining, no, necessary but not sufficient. And with example also I have shown you. Now here we are
ma'am,
using some notation. Please let me complete the class. Let r equals to del 2f del x2, s equal to del 2f del x del y, t equal to del 2f del y2. So these notations we are using r as t at x equals to a, y equals to b. Now, as a set of necessary condition for maximum or minimum, we already have seen that del f del x should be 0, del f del y should be 0 at the point AB. So I'm not going with the derivation, I'm coming directly to the result. F is minimum if RT minus S square greater than 0. and r greater than 0. F is maximum if rt minus s square greater than 0 and r less than 0. Okay, so this is the sufficient condition. We'll do some problems so it will be more clear that how we are considering this one.
How
Just
this is
remember
coming?
how this is coming. It's a long derivation which I am not going to explain. It is not also in your syllabus. You only need the result to do the problems. Okay.
Okay,
If
ma'am.
you want to know, then it is already done in any book. If you open, the derivations are done.
Ma'am, earlier you have provided two equation, the necessary condition for extrema h del f upon del x plus k del f upon del y equal to 0. How it has? Can you explain, ma'am?
Better no, let us complete the class. Let me upload the material and you people please study a bit. Don't ask so much of questions while taking the class.
What is the use of doing class, ma'am?
Don't do. Who asked you to do? Have I asked you? Anybody asked you to do the class? Nobody asked you. Don't do. There's so many videos, so many lectures, everything is available in the market. Go and do it. If you feel the class is not of use, please don't do. Attendance is not compulsory. Nobody asked you to come and sit in the class. But I have to complete my syllabus, so I have some target which I have to complete. How come you can talk like this? I don't understand. To a teacher, you are saying that what is the need of doing the class? Do you have the guts to say in front of me whatever you are saying? Do you really have the guts? Can you tell your name? How dare you talk like this? Don't do the class. Nobody asked you to do the class. Doing as if means if you do the class, I'm going to get my salary, otherwise not. Even if I don't teach now, I'm going to get my full salary. Every teacher is going to get their full salary. Even if you understand, even if you don't understand. Doesn't matter. But still we try to at least make you understand. There are so many students of different merits. So we have to go like that. Learn some manners, okay? Before talking, no, just think what you are saying. As if you are doing online class means you can say anything. Who said this? May I know the name? May I know the name? Who said this?
Deepak.
What's your roll number, Deepak? Deepak, I would like to know your roll number. Tell me your roll number. Deepak, I want to know your roll number. Can you tell your roll number? Where are your guts now?
I have written in chat box, ma'am.
No, you tell me. I want to just write it down.
21C 80003.
21C?
80003.
Okay. Before commenting,
Ma'am,
Before commenting, just think what you are saying.
Understood, ma'am. My points of view. मैं तो क्वेश्चन नहीं पूछ रहा था मैम आपसे.
नहीं ऐसे करके बात मत किया करो ना.
मैं 2 बार
क्या है क्लास करने का? क्यों ये सब बात कर रहे हो? कौन बोला है तुमको क्लास करने के लिए? कोई बोला है तुमको?
मैम
इज इट कंपलसरी?
सुनिए तो
सुनो,
मैम.
टीचर के ऊपर भी ना प्रेशर रहता है. वी आर टेकिंग 5 सब्जेक्ट्स. डोंट फॉरगेट. बीटेक, एमटेक, एमएससी, so many things we are taking. Keeping 5 subjects in my mind, we people are teaching you. सुबह उठ कर तुम लोग को पढ़ा रहे हैं ताकि we can make you understand something. Try to understand other person views also. When teacher is teaching something, teacher is trying to give you something. ये कैसा बात हुआ? मुंह के ऊपर बोल रहे हो? फिर क्लास करने का क्या जरूरत है? मत करो. कहीं पे लिखा हुआ है क्लास करना जरूरी है? कोई तुमको बोला है सुबह उठ के क्लास करने के लिए? I ever asked you? कोई भी टीचर तुमको बोला है क्लास करो? मत करो ना. If you are so intelligent, you can manage yourself. Please go ahead and do it. हमारा क्लास करने से भी तुमको कोई फायदा नहीं होगा, और अगर नहीं भी करोगे ना तुम्हारा कोई नुकसान नहीं होगा. कम से कम बात करने से पहले ना थोड़ा सोच के बात किया करो कि व्हाट यू आर सेइंग. Okay. Stationary point or critical point. Follow. The point AB is said to be stationary point or critical point if fxab equals to 0 and if yab equals to 0. What is fxab? Del f del x at the point AB. It should be 0, and del f del y at the point AB it should be 0. Another term is saddle point. So stationary point is also known as critical point. So wherever we'll get the first order partial derivative 0 at the points, those points will be known as stationary points or critical points. And which points are known as saddle point? A point AB will be known as saddle point if fxab equals to 0 and fyab equals to 0, but fxy has neither maximum nor minimum at AB. Let me just draw the thing, it will be more clear. Say this is my fx, say, and this is my x-axis. So let my curve be something like this. So at all these points, the first order partial derivative will be 0, no? Parallel to x-axis. So all these points are stationary points because definition of stationary point was what? Del f del x at that point AB will be 0, del f del y will be 0. So all these points will be stationary points. Among it, this is the maximum point. And I can say this is minimum point. And what about the other points? Other points are, I can say they are saddle points. So this one, okay. Then this one, all are saddle points. So can I say that every saddle point is a stationary point?
Yes, ma'am.
Yes, ma'am.
Every saddle
Yes,
point
Yes, ma'am.
is a stationary point. Can I say that every stationary point is a saddle point?
No, ma'am.
No,
No,
because,
ma'am.
No, ma'am.
because maximum and minimum point are not saddle points. So we can say that
Ma'am,
every
here,
saddle point is a stationary point. Yes,
ma'am, fx means a derivative with respect to x.
yes. fxab means del f del x at ab. This. So first we are going to find the first order partial derivative with respect to x. Then at the point AB we are going to find it out. So we know that parallel to x-axis the first order derivative will 0 means. So this is the situation. So all these points we are saying these are all stationary points. Among the stationary point, one is minimum point, other is maximum point, and remaining are known as saddle points. So I believe that you understood what is stationary point and what is saddle point. The difference you understood.
Yes, ma'am.
Yes.
Okay, now just let us take one example. One function is given x cube.
Ma'am,
Plus
but one
y
thing I
cube.
have to,
Yes. Tell me.
ma'am, the region we are considering for the finding of the stationary saddle point is very small, and
Hmm.
the thing
Hmm.
which you have written here is global, like
Hmm.
it is whole interval. So then, how
Hmm.
can we differentiate in that respect?
No, this one only for making you understand the difference between saddle point and stationary point. I have drawn this one. Okay. Don't confuse this one with the definition. It's only to make you understand that what is the difference between saddle point and stationary point. I drawn this. Okay. Now the question is find the maximum and minimum values of the given function, and also if there any saddle point. So first thing is what? First thing we need to find out what is del f
Del F X
del x, and we need to find out what is del f del y,
by del
and then we have to
And
make
what
them
is the
equal to
point?
0. What is the point? That we have to find out, no? We have to find out.
Okay, ma'am.
So how we will find out? By making the first order partial derivative 0.
Yes, ma'am.
Yes, ma'am.
So what is del f del x? 3x squared minus 3ay. What is del f del y? 3y squared minus 3x. So we'll make this 0, this 0, and now we will solve it. If you solve it, what you are going to get?
Okay, ma'am.
X equals to under root AI plus
We will
minus
get
something.
we will get points, no? We'll get the stationary points.
A comma A minus A comma A minus A comma A.
A comma a minus a comma a.
Yes,
Zero
ma'am.
plus or minus.
Ma'am, 0, 0, A
0,
comma
0.
A.
Correct. We are getting two stationary points. Stationary points are 0, 0 and AA. So first job, whenever we are getting a function, what we are doing, we'll first find the first order partial derivatives. We'll make it to 0, and first we'll get the stationary points. After getting the stationary points, we will now check that whether these stationary points are maximum point or minimum point, or they are saddle points. Okay. So now we got the stationary points. Now next job will be to find what is fxx. What is fxx? 6x. What is fyy? 6y. What is fxy?
Minus 3.
3a. Now at the point AA, we'll try to find the values. So at the point AA, fxx will be 6a, fyy will be 6a, and fxy will be minus 3a. Now we'll find out RT minus a square. Remember I have written that RT minus a square should be greater than 0, and depending on R, we will be telling about whether f is minimum or maximum. So R into T.
What if R is 0?
We'll come, don't worry. We'll come to that case also. We'll come to that case also. If r will be 0, what will happen? So this is rt minus a square. So what is the value of this? 36a square minus 9a square. Now, is it greater than 0 or less than 0?
Greater than 0. Ma'am, greater than 0.
Greater than 0.
Greater than 0.
So rt minus s should be greater than 0 to get f to be minimum or maximum. That we know. Now, depending on the value of r, we will be able to say whether f is minimum or maximum. Now, what is r? R means fxx. Fxx is what? 6a. Now,
Minima.
how? If
Greater
a
than
is,
I mean, depends
it
on the value
depends
of
on
A.
a. Yes, it
A.
depends on value of a. If a is positive or negative, accordingly we can say no.
yes.
Yes, ma'am.
So f will be maximum or minimum depending on whether a is negative or positive. No, that is what we know. That if a is positive, then f will be minimum, and if a is less than 0, then it will be maximum. So for this, we will write that f has a maximum or a minimum value at AA depending on whether A is negative or positive. So this
मैम हियर RT माइनस इसमें मैम A स्क्वायर है ना मैम,
हाँ
तब तो पॉजिटिव हो जाएगा ना मैम.
हाँ A square
तो
है
मैम
6A.
मिनिमम कंडीशन
No,
कैसे, मैक्सिमम कंडीशन कैसे
that
set
will be
होगी?
always positive,
क्योंकि
but there is another
maximum के लिए तो
condition
वो
on
RT
RT less
minus
than
A
0.
square should be greater than 0. Then only we can proceed. Okay. So RT minus A square we got positive. So now we are checking for R. So when we are checking for R, what we got 6A. तब A क्या है उसके ऊपर डिपेंड करेगा ना, A पॉजिटिव है कि नेगेटिव है. So we don't know because nothing is given in the problem.
Okay.
That take A positive or A take A negative, nothing is said. So we cannot conclude. But it is
तो
sure
मैम
that depending on A,
RT minus S square greater than 0 होता है.
height should be greater than 0. If it is equal to 0, then we cannot proceed only. We'll come to those
Okay.
sums also. Don't worry. We'll come to those sums also. Okay, so for this, I think it is okay. Now we'll check for 0, 0. Because we have another stationary point 0, 0. What about at 0, 0? What is fxx at 0, 0?
Every parameter will be 0.
0.
Zero.
O minus 3a. So what is RT minus S square?
0.
How? Minus 9a square. It is less than 0. Hence, 0, 0 is not an extreme point. Okay, because RT minus S square should be greater than 0 for being the maximum or minimum value. So here RT minus S square is coming less than 0. So 0, 0 cannot be any extreme point. So here 0, 0 is actually a saddle point. Is it clear? This problem is clear now?
Yes, ma'am.
Yes, ma'am.
Yes.
Yes, ma'am.
Yes, ma'am.
Okay, let me just do another problem and then I'll finish the class. Okay?
Ma'am,
Yes.
if RT minus S square will equal to 0, then what we will conclude?
Let me come to that now. Why you people are jumping? We'll come to that. When RT minus S square will become 0, no, that condition will come. We'll solve some problems on that also. Now this function is given. So first job is to find what? First order partial derivatives.
partial derivative.
We will make them.
Yes,
We
ma'am.
will make them equal to 0.
point.
Yes, and we will find the stationary points. That is our first job. First job is to find the stationary points. So please find the stationary points. Make your first order partial derivative 0. Solve them and get the values of stationary points.
1, -1.
So we have to find
Ma'am,
del
x equals
del
to
x.
plus minus 1.
Y is equal to plus minus 2.
X equals to plus minus 1.
Plus or
Y
minus 1
equals
plus
to
or minus
plus
2.
minus.
Y equals to plus
So
minus
how many stationary points?
4.
4 ma'am.
4.
Yes. Yes. We have 4 stationary points. So next job क्या है? हर एक point में we have to check. Yes.
Check.
हर एक
We are
point में we
into
have to
mode
check whether it is maximum point or minimum point or saddle point. That is what we have to check. So we have the points 1, 2. We have -1, 2. We have 1, -2. And we have -1, -2. So these are the 4 stationary points we are having. Now at every point we need to now check whether these points are extreme points or they are saddle points. Now start with the first point at 1, 2.
Ma'am, fx is 0.
क्या मिल रहा है at 1, 2? We have to find out fxx. What is fxx? 6x. 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 Fyy is
6y.
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 And what is fxy?
3.
0, no? So at 1, 2, at 1, 2 point, what you'll get? This is, if I write fxx at 1, 2, it will be 6.
Yes, ma'am.
Fyy at 1, 2, that is 12. And fxy at 1, 2 is 0 only. So RT minus S square
Is positive.
it is coming what? 72. No? Greater than 0.
72, yes.
Now, what is R at 1, 2?
6.
Positive 6.
Positive.
6.
Minimum.
It is minimum.
6. Therefore,
Minimum.
1, 2 point is minimum.
Minimum.
1, 2 is a point of minimum. So you understood. So in the same manner, we have to check for other 3. So I believe you can do it. Okay, same technique.
Yes, ma'am.
Yes.
So here you'll get, you already got the minimum point. You'll get one maximum point and other 2 points will be saddle points.
Maximum will be -1 -2.
Yeah, we'll have the maximum point as -1, -2.
Yes, ma'am.
Yes, ma'am. -1 -2.
Yes, ma'am.
And we have to also tell that what is the minimum value. Like if 1, 2 we are saying point of minimum, then what is f of 1, 2? That also we need to say.
Substituting.
Okay,
We have
ma'am.
to
We
put
have
the
to
value.
put these values in
Put the value,
XY.
yes. We have to put the
Ma'am,
value in fxy and we have to say what is that value. We need to talk about the point and also the function value at that point. So if you put f1,
Okay, ma'am.
2, I think you are going to get
2 ma'am.
2. Yes, correct. So in the same manner, please check for other 3 points. Okay. Okay, so in the
ma'am.
next class, we'll continue with the cases. Many cases are there, like RT minus S square. If it comes 0, then how to handle. Okay, all these cases we will discuss in the next class.
Yes, ma'am.
So till this, it is, yeah,
In CS12 sports
Ma'am,
only,
maximum minimum is included in our midterm examination.
yes, whatever taught till today.
And ma'am, mode will be MCQ or subjective?